This is just a short video to illustrate the behavior of electrons and the different types of chemical bonds. So I have ionic bonds, covalent bonds, and metallic bonds all on your screen. So we know ionic compounds are formed through the transfer of electrons from a metal to a nonmetal. So the electron behavior there is a transfer from the metal to the nonmetal. So in this case, sodium is our metal, fluorine is our nonmetal. Sodium loses its one valence electron to fluorine. This creates a positive charge on the sodium and a negative charge on the fluorine. That is what holds the atoms together. And those charges come from the transfer of an electron from the metal to the nonmetal. When we take a look at covalent bonds, we have something different happening. Where the ionic bonds have a loss of electron and a gain of electron, that's because our metals have very low ionization energy, which means it's easy to take their electrons. Our nonmetals have very high electronegativities, which means they're very good at stealing electrons. So that combination allows nonmetals to steal the electrons from a metal, creating oppositely charged anions, which hold the atoms together. So in ionic bonds, the opposite charges are what holds the two atoms together. Covalent bonds are different because covalent bonds only include nonmetals. They all have relatively high electronegativity and ionization energies, which means nobody can really steal electrons from another nonmetal. So instead of stealing electrons between two nonmetals, we're going to share them, which you can kind of see here in this incredibly fast GIF. So when I put two nonmetals in close proximity to each other, they'll try to steal each other's electrons, but it won't work because they're both very electronegative. So instead of stealing, they will share the electrons. Now, these shared electrons are what hold the two nonmetal elements together. So shared electrons are what hold covalent bonds together. They're also what make the covalent bonds. So covalent compounds share electrons through covalent bonding. Metallic bonds, so here's a metal. When we look at it at a microscopic level, we see that those electrons are not following one particular pattern. They're not being transferred. They're not being shared between two atoms. They're just kind of floating around lazily. We call this the sea of electrons. So in metals, we have a sea of delocalized electrons, meaning these electrons are free just to cruise anywhere in the substance they want. They are free flowing electrons. So in this metallic substance, we have free-floating electrons, delocalized electrons, sea of electrons. All of those names are perfectly fine to call these electrons. But these free-floating negative charges just kind of move in between all of our positive charges, holding that substance together. So this metal, at a particle level, we can see free-floating electrons. The negatives attracting to the positives are what hold our metallic substance together. So again, to summarize the electron behavior between ionic, covalent, and metallic bonds, the electrons are transferred from the metal to the nonmetal in ionic bonds. The electrons are shared between two nonmetals in a covalent bond. And the electrons become delocalized into a sea of electrons, which are free to float around amongst any of the metallic nuclei in a metallic substance.